Okay, good morning everyone and welcome to grade 7 coding. It is the 8th of July today and we are going to be doing functions in the harvester. The same as what we did yesterday. So I just want to talk through a few things again and then we can get going to start coding on this and practicing our use of functions, right? So all of our technical things have now been sorted and it is in place, so we are good to go. For those of you that are back for the second time or the third time, welcome. And if you are back for the 100th time, also welcome. If you are new, we are glad to have you here. So I just quickly want to run through a few basics. These videos do get uploaded to YouTube, so if you do miss them, you can always go and catch them there. We are busy working on our YouTube channel to give it a nice facelift and an upgrade to make it more user-friendly and to make it just stand out and look a bit better. So that is an ongoing process. We have a lot of uploads there. We have 76 uploads happening in a day. So that is going to take some time to get it all sorted, but it will get there and it will get sorted eventually. So for those that are perhaps watching the recording on YouTube, if you go down to below this video, there are links there that you can register to if you have access to an email, or if you do not have access to an email, you can ask a parent to register on your behalf. Then you can also receive the links to these lessons so that you can come and join us in the classroom and then have access to the chat box and to the links that I am sharing so that you can also code on the platform that we are coding on. That being said, the chat box, we do have to maintain some sense of order in there. So please only keep your questions relevant to what you see on the screen. And then also, it allows you to have access to the links that I share from your side. Please do not share any links. It just causes a few hassles for us because we need to make sure that everyone's online safety is taken into account. Okay. Lastly, please try to keep your video cameras off. It hasn't been a problem in my lessons. I teach senior phase, so I assume that it's because you guys are a bit older, you are more comfortable with using computers and technology. But if you do accidentally switch on your video, just switch it off again. We will also assist you from our side. The only reason is if it is switched on, I cannot see the screen, and then it makes it a bit difficult for me to discuss the content that we are working through with you. Right, so let us get into this. Here's a new quote today. Learning to write programs stretches your mind and helps you think better. Creates a way of thinking about things that I think is helpful in all domains. And this was said by Bill Gates, and he is the co-founder of Microsoft. So what he is basically saying here is when you start working with computer code and coding and programming, and you start to create programs or you start to create games or apps, it stretches your mind. And in his opinion, it creates a way of thinking that you can use in every aspect of your life, okay? As programmers, we are generally, our job is to solve problems, right? So we do it by way of creating computer code and creating programs that can do certain things for certain industries. But that same mentality can be applied to many other aspects of life where you can solve problems using the same methods that we use to create code and to solve problems, right? So if you just think about the problem solving workflow, which we discussed last week, you can apply that problem solving workflow to almost anything that you are doing where you are facing any adversities or problems, even in life, not just with physical things that you're doing, right? So now I just want to talk on these quickly. We looked at a sequence yesterday for the first time, and the sequence is the main logical structure of algorithms and programs, right? So when we refer to programs, that entails programs like Microsoft programs, Word and Excel, PowerPoint, Windows, all of those things. It also refers to games and apps as well, right? The same sequences are used for those also. So what a sequence basically is when we compile a few lines of code together, or in our case, blocks of code together, which has a function, it does something, that is referred to as a sequence. Now, there are no limits as to how short or how long a sequence has to be for it to be defined as a sequence. So in my approach, I like to define a sequence as a set of code that does a specific one thing. So I might have many different sequences within a program or within these puzzles that we are solving. Okay, then we have to have a look at conditionals. So conditionals are if-then logic statements that changes the way that the code is executed. So if you take, for example, we have a move forward and then a turn left block. So what would happen there is we would move forward and then we would turn left, right? It doesn't matter. There are no other factors being taken into account there. It's going to try and move forward and turn left, whether the map allows for that to happen or not. It doesn't take the restrictions of the map into account. But if we use an if-then logic statement, then we can say, if there is a path ahead, then you move forward. And if there is no path ahead, then we want you to turn left, or we want you to collect something. As we saw with the harvester yesterday, where we had the pumpkins at the end of the path. If you are using an if repeat, a conditional repeat, you can tell the harvester to move forward until there isn't a path anymore and then to do something else. Okay. So it just gives you a lot more functionality within your code without having to write longer sequences of code to achieve the same result. Right, so I just want to, or have to, talk through these one last time. From tomorrow, they won't be in here anymore. It is just because of the way that the harvester puzzle has things set up. So we used to have a toolbox with all our blocks available, but now we have just too many blocks for us to choose from. So they've been divided into different groups of blocks that all have the same, or all act in the same way. They all do the same thing. So the actions are very easy to understand. These are the actions that the character will perform. Loops, those are the ones that we use when we want to make a sequence repeat, okay? Conditionals, as we've just said, it is something that looks for a condition to determine whether the condition is true or false, and then it will act according to that, what it has seen and what it has found, okay? Now you need to understand that there are also conditional repeats like these ones, and if you go back to the repeats, all of these ones are conditional repeats. So there are two different types of repeats. The one repeat is where we loop it a predetermined number of times, where we can set the number of how many times we want this to happen. The other one is a repeat that will only happen in certain conditions. So like this one at the bottom, this will only, this one at the top is going to repeat as long as there are pumpkins on the map, okay? This one is going to do whatever we put in here while there is a path ahead, but if we want to move forward while there's a path ahead, then we have to actually put a repeat in this one as well, okay? So here we have allows you, functions, there we go. It allows you to call a specific frequently used sequence. So we can use this stop block here. Sometimes we will be applied or supplied with functions that have been defined by the program itself. We just always have to make sure that we understand exactly what is meant. So we need to look at the sequence that is being represented by this function. So it says check square for corn. So we need to make sure that check square for corn is the character only going to check if there is corn, or if there is corn, will it then also do something, right? So we need to understand the sequence behind the function. If not, then we can create our own function here. We can type in anything that we want to do there to label it in a way that we understand what it means. Now, remember, it's always good to take into account that in future you might be working in a group and you might be working in a team. So you want to use labels that can be easily understood by whoever else might be working on your code. So we'll put that in there, and then we create the sequence ourselves that we want to have this function call to. And then there will be a new function under the functions tab that will allow you to choose that function. Okay. The last one is a comment. So we did speak on comments yesterday. I'm not too stressed about that. Okay, today we are continuing with functions in the harvester, puzzle 5 to 9. So I want to jump to the coding screen before we do. Okay, that's the next lesson. Let me just go there. Okay, so for those of you that are new, you can see here that we have obviously done a lot. The grade 7 class has been running from the start with regards to coding. So we have completed all of these lessons before. We are now down here at lesson number 17. We still have quite a few to go before this entire course that we have on code.org is finished. But if you are new, or if you're watching the YouTube video, then you can just go to code.org. You can sign up for an account or ask a parent to help you. It is absolutely free. And then you can have access to all of these so that you can start catching up. Alternatively, if you are in the lesson, you can just keep the link that I share with you open, and then you can access it that way as well. So I just want to look at puzzle number 4 again. You know that we have to do review, and I'm not going to code it again. I just want to talk on it. So here we can see this is, let me just share the link before we get going. My Zoom controls are in the way. Let me just move that up and open the chat box again. And there is the link. So while you are going to navigate to that, this is why I always repeat the first puzzle so that you have time to access what we are doing while I am discussing everything. I'm just going to move this to that side. Okay. So here we can see we have the harvester there. We want to move forward, and then what we have to do is we need to use the function to help the harvester pick the corn and the pumpkin. So now it's going to tell us each sprout will either grow 1 corn or nothing. So there you can see there are 1, 2, 3, 4, 5 sprouts. So each sprout will either have 1 corn, the same as that, or it will have no crops growing there. Okay, so what we have to do is we need to check for corn each time we get to one of those. But we can also check for corn on the empty blocks. It's not going to cause an error on the code, which makes it easier for us, so we don't have to determine exactly when the harvester is here. The harvester needs to check. We can actually make a check everywhere, which allows us to repeat it. So what we said here was we want to repeat until they are pumpkins, move forward and check for corn. Now this small repeat here and these two, that in itself, let me just remove that so that you can see it more clearly. This is a sequence, okay? Now, as I said, I refer to sequences according to the function that they are performing or to the action that they are making the character do. So we can see this is a sequence that we have here, and this sequence is just going to make our harvester move and check for corn, okay? But it does not make our harvester turn or pick the pumpkin. So what we need to add then is another sequence that is going to make our harvester turn and then pick that pumpkin to be aligned up there. So we can run that, and now you see that is there. Okay, good. And we can see our function is checking if there is corn, pick the corn. Okay, so this says check square for corn, but it is not only checking, it is also picking the corn if it is there. Okay, so what we can then do is take this entire thing and either copy this down here again to do that top part, or we can take the entire thing and put it inside a repeat. So this would be a nested loop then, and now we can just run it by using a lot fewer blocks than what we would have if we were to write that last sequence again. Okay, so there we can go. That works well. So now we can, if this allows me, okay, I'm just going to force it to jump to the next puzzle. Okay, good. So I think we are good to go. So this is saying, I feel so functional. Now there are multiple pumpkins in each patch. Look carefully at the function definitions below to figure out how to use each one. Each sprout will either grow 1 corn or nothing. Okay, so this one I left you with for homework. So I want to discuss it now. And some of you did do this, and I received some emails as well. So thank you for that. I think I did reply to all the emails. If I haven't yet, I'm sorry about that. Just know that I did receive it. Okay. So the sprouts, nothing changes there. But what does change is we do not know how many pumpkins there are. There might be 4 here and 1 there, or there might be 0 here and 1 there. We don't know. So what we are going to do is we are going to use this new function. Now this function was defined by the programmers of code.org for us to use. So this one remains the same. Check square for corn stays check square for corn, and it will check and pick if there is corn. Get all the pumpkins is the new function. So you will see under functions, there it is, okay? So this is saying while there are pumpkins, pick the pumpkin. So this is going to repeat the pick pumpkin action as long as there are pumpkins. So when this condition is true, while there are pumpkins, it's going to do this until the condition is false, okay? So now we have that in a function. So each time we want this to happen, which is going to be twice, we can just call on the function. We don't have to write that entire code again. So before we even get into that, now we understand what we have to work with. We need to follow our problem-solving workflow. As always, I just want to adjust this. There we go. That's better. So our problem-solving workflow dictates that we have to solve the easiest problem first. So we break this down into smaller problems and solve the easiest one first. The smaller problem is we need to get the harvester from there to there, right? Now we know we're going to do that in a loop. But before we start placing loops on here, it's always better to create a sequence, even if that sequence just does one block, so that we can be sure it works before we loop it. Because once we start looping it, some of these puzzles, it hasn't happened yet. But if you create a loop and the sequence is wrong, this character just runs around like crazy. So you can't even see where the mistake was. Okay. So that's why I say test your sequence before putting it in a loop. So now we can see the next thing we have to do is we need to use a function to say check the square for core. Okay, so if we run this, we can see it's not going to run now. Let me just see. Oh, there it does. It's just a little bit slow. But it's moving forward and it isn't giving us an error saying that we cannot check the square for corn or whatever. So we know that we can use this function even on the empty blocks. The only thing it's saying is don't leave crops behind. So that's cool. We now know we can loop this to make this harvester go all the way to the end. Now we need to choose which loop do we want to use. So we realize that this while path ahead loop is usable. Yesterday we saw that, but we can test it again just to make sure. Okay. But we also realized then later on, it works at the bottom. But at the top, it doesn't work because the pumpkin is not at the end of that path. The pumpkin is before the end of that path. And we will likely repeat this entire section again or sequence. So it is better for us to just use the repeat while they or until they are pumpkins. So what this is saying is check for a condition. As soon as there is a pumpkin on the block that she is on, this repeat will stop. So we can test that. And you can see once she gets to the pumpkin, it stops. Okay, the code doesn't keep running. And I hope that you've noticed a few times now, the amount of pumpkins differ every time we run this. Okay, so now where yesterday we said, pick the pumpkin, I want to show you, if we do it this way, it'll still work, but it's only going to pick one. Then you can see it goes from 3 to 2. So we need to find a way to pick how many ever there are. And we can't put 5 pick pumpkins because as you saw, 2 turns ago there were 5, the previous turn there were 3. So this is where we're going to use this function here. This function says get all the pumpkins, right? So it's very easy to understand. We see what it does and we test it again. Just allow it to run. It's a little bit laggy today. And there we can see, awesome. So now we have 2 sequences together and they can form one sequence to become the solution for this entire row at the bottom. Now we need to find a way again to get our harvester to move up there. So what we're going to do is we are going to turn left, the same as yesterday. We're going to move forward twice. One, it has to be connected, remember that. Move forward twice. From here, we turned left, we're moving forward twice, and we're going to turn left again. Okay, now you should be able to see that this row at the top and this row at the bottom, they're going to have the exact same solution. So let's just run this so that you can see it visually. Okay, collecting all of that. Now over here, the harvester is facing this way. And this looks very similar to what we had down there. So it stands to reason that the same solution that worked here should work there. Remember, we already have this solution in here for that small part there. So what we can do is just to type that entire code again or to add it in the blocks, or we can just loop this entire thing one more time. Okay, now this loop will only run until there are pumpkins. So remember now, it's going to do all of this over and over again until she is standing on a block where there are pumpkins, right? And when there are pumpkins, she's going to get all the pumpkins. If I can get it to run, there we go. And then the code will stop automatically because it has executed everything that needs to be executed. Good. So here you can also see what I meant. If we use this while path ahead loop that we have here, this one, it would have worked at the bottom because the pumpkin is at the end of the path. But at the top, it doesn't work because the pumpkin is not on the last block. It is in front of it. Okay. I just need to reset this and run it again to see if it'll allow me to pass through. Tell me, are you all happy with this? Just type a yes in the chat box if you understand, and we can move on to the next puzzle. Good. So you can put these at the bottom if you'd like. It doesn't matter. When we're writing it in code like this, then it'll be at the top. We need to declare our functions or define our functions before we start with the actual sequence. I just put it here off to the side so that we can actually see it when we are working. Okay. If yours is doing the same as what mine is doing, so you played it through and it doesn't give you the screen to continue, just click on the next puzzle. Okay. There at the top. I don't know today, code.org seems to be a little bit tired. Okay, so great. Try your functions out on a longer path. So I'm going to share the link again, not necessarily because I think you might have lost it, but just because it helps me to manage the chat box a bit better. Okay, so here we have 25 blocks to write this code in. I'm sure we can do it in less. Okay, I'm very confident that we can do it in less. So what we have here is the same thing. Here we have a path, then we have an unknown amount of pumpkins. Then we're going up, we're going left here, and we have one pumpkin there. And then here at the top, we have another path with the sprout, and we also have an undefined amount of pumpkins. So it doesn't tell us how many corn crops there might possibly be. So if we look at the function that they gave us, we can still assume that there is only one. If you want to be sure, click on run, and it should reveal the amounts, okay? And you can click on run again to make sure it doesn't change the next time, and there we go. So it stands to reason that there will be only one corn or zero. So let us get cracking with this. We want to create a solution for the first problem only. Moving from here to there, collecting the corn, getting all the pumpkins. And we've done that already, so we don't even need to really discuss it in detail, right? So what we, no, this one functions. We're going to say check square for corn there, and we're going to repeat it until there are pumpkins. Now this sequence should have been easy because we've done it before now a couple of times. Okay, I missed the last one, so we just want to add the get all pumpkins there. And now, because we are doing so many different solutions, I'm going to add a comment in here. And you'll see that with the comment, it doesn't add a block there. You can see if I remove it again, right? We are now using 7 because we've defined the functions. We add this, we're using 11 because our sequence is added. When we add a comment, we are still using only 11. The comment does not count as a block. So this is going to be our first solution, okay? Or let's say, rather make it a bit more clear, bottom row. So it's going to tell us it's this bottom row. And this is only if we see that we encounter problems and we have to debug, we can come back here. You can see it here in the code as well. There is our comment, okay? And it's going to allow us to know where we want to adjust. Imagine you need to fix problems on an entire program. You get to that program, it looks like this. The code looks like this. You don't know what does what. We don't know. Here we can see because we're reading what they do, and here we can sort of see, but isn't it easier to just look for bottom row? So if we look at the program, we see the problem is there. We go to the code, we just scroll to where we see, oh, there's a comment for bottom row. So our problem is here. We need to fix it here. We don't have to mess with anything else. Okay. It avoids a lot of confusion if you use comments, and data management is a big part of coding. Okay. So now we need to obviously move up here again. That's going to be the same as what we did before. So we're going to turn not right, but left. You can switch the toggle. That's fine. Add 2 move forwards in here. And we are going to turn left again. Just choose the right one. And I'm going to add a comment here to say this is our first turn, right? Now we know first turn is not only this turn here, it's this entire sequence here, right? So that's why I said when you use these comments, you just need to make sure that the next person that works on your code also understands what it means. Okay, so now we can see that this is obviously going to be the same solution over here than what we had there. So let us test and see if we can repeat everything. So this repeat goes on there. Everything along with the comments goes into that. Okay, but I do think that we might run into a few problems here. Okay, so you see what happened there. After she collected that pumpkin, she actually started to do this sequence here, the first turn sequence again. And that doesn't help us there. So instead of repeating everything, and that's why we test so that we can make sure, we're going to add some more code here. Okay, so if we do this, right, we're going to see she should stop there. Okay, so now let us code that, and we don't have to think about that. We can just add a comment in there that's going to say second row, and then we already know the sequence works. So we just need to do this again. So for that, we can now start with the repeat because we already know the sequence. So we're not testing a sequence before we repeat anything. Want to check the square for corn. Now here there's only one pumpkin, so we don't need to use the function again, although it shouldn't create any issues if you do use the function. Okay, now if we run this, we can see it's going to do this until she is on a pumpkin. Right, there you can see, and then it does that. Awesome, so that works. Now we need to get from here to there and face this way. So now we can add another move forward. Okay, before we do that, just to make sure we still understand, we can say that this is our second turn, right? And on this one, we are going to be turning right. Okay, so I'm going to run the code again so that you can make sure that you see everything and understand it. It's much easier when we visualize the code. We actually see it running. Okay, and look at that. Now we are in a position where we can say, okay, we can create this sequence again. We need 1, 2, 3, 4 blocks to create that sequence. We have 4 blocks available. But let's see what will happen if we repeat everything now. Okay, because this sequence in here, this bottom row solution, is the same for that. So let us see if it's going to work. The only thing I'm not sure of is if I read the way that they've labeled it, it stands to reason that it should stop after all of them are collected, but perhaps it doesn't. Okay, there you can see it doesn't stop. Okay, so when it got all the pumpkins, it actually continues to try and run this code. So we will not be able to repeat that. We're going to have to remove this repeat here. Perhaps there is a different repeat that we can use. I don't know. But for now, let us just add it the way that they want it to happen. So then we can say we have our bottom row, which we can leave as a bottom row. Then we have the second row. Now we can have our third row. And our third row is going to again look like the bottom row. The same thing. The reason is there are an undefined amount of pumpkins up there. Okay, so we want to move forward again. We want to check the square for corn, and we want to get all the pumpkins. And now we've used 25 out of 25, and we have written a massive amount of code here. But although we have 25 blocks of code in this sequence, right, including the functions, our things are labeled so we can understand what we're looking at. I want to show it to you here. Look at this. Now imagine all of this code here without our labels. After turn right, it's just going to jump into while there is a pumpkin, do this, do this, do this. Okay, so you can see that using comments to label our different sequences within the program is very helpful when you are writing code in text and line-based form. It does help for this as well. You saw that especially when we did all that art with the stickers and with Anna and Elsa. Actually, it wasn't with the stickers, it was with Anna and Elsa. In that exercise, it's good to use comments because in some of them, the puzzle changes slightly and you just need to restructure the code, okay? So without me rambling on too much longer, does this make sense to you? Type a yes if you are comfortable with this. If you are not, please type a no. I will just talk through it again. We won't write the entire code again. I'm just going to talk through it because I want to make sure that you really understand this. From here on out, it is not going to get easier. From here on out, it is going to get way more difficult. Safiso, how are you doing? Are you good there? Angelina, are you happy with this? Do you understand it? I see Jesse is happy, but Jesse has informed me that he has coded before in Java and JavaScript. Angelina is happy and Safiso is happy. Okay, good. So now this was the most difficult one that we were going to do for today. So I'm assuming the next one is going to be of such a manner that you guys can tell me how to write the code. I think if you are really comfortable with it all, then I'm going to ask you in the next one to tell me in the chat box what we are going to do here. Okay, so there's the link again to allow me to navigate the chat box. Okay, let us read. Did you notice that there was a lot of repeated code in the last puzzle? We can save space by calling that code pick along the path and using a new function to call the other functions. Wow, look at that. Use pick along the path to solve this puzzle, again, using fewer blocks. Okay, so you saw earlier what I tried to do was to repeat everything to save space. Now they said, instead of trying to save space using the repeat over everything, let us create a function for that. So you saw this, repeat until there are pumpkins, check square for corn, move forward, or move forward, check square for corn, it doesn't matter. Get all pumpkins. This code we repeated twice in the previous exercise. Now they've put it into a function, pick along the path or pick along path. Okay, so now we can make it much shorter. So in your opinion, in the chat box, quickly tell me, which one do you think we should put first? Are we going to create this entire sequence again, or can we just drop that function in there? So type in the chat box, sequence or function. Jesse says a function, right? And that is correct. We are going to call pick along path function. And we can see the code is going to repeat until there are pumpkins, check for corn, move forward, get all pumpkins. Okay, so we will run this just to test and look at that. And I want you to quickly, I'm going to put this side by side so that you can see this a bit more clearly. I want you to see that when these functions are called within this function, you can see the code running on these functions. So don't look at the play area now. Look at our workspace so that you can see how they light up, okay? When each code is running, when each block's code is running, it will highlight in yellow or orange. So just check. When we run there you can see it jumps. Look at that. Okay. So what this is telling us is as we can have loops inside loops, so we call those nested loops, we can actually put a function inside another function. So you can call functions not only from sequences within your program, you can call them from inside other functions. And if we look at the code, you'll see that there is the function to check the square for corn. There is, let me just go down to this one. There is the function to pick all the pumpkins. Here is the function to pick along the path. And there you can see function check square for corn. There's check square for corn. This label is in here. And this one, while there are pumpkins, get all pumpkins sequence, there function, there it is, get all pumpkins. So you can see within this function, we are calling on other functions. Okay. I know it's getting complicated. I really understand it. So please, please, please slow me down if we are going too fast. Okay, so now that we've done that, okay, we can again use a comment to help us understand this. And we can call this the first row. So what do we need to do to find the solution for this first turn? Type in the chat box for me what blocks you would like me to put into our workspace to do that. You can type block for block. You don't have to type because we're going to use 4 blocks to find the solution. So you don't have to type that. You can just type 1 block. Turn or move forward or repeat, whatever you want. Turn left. Yes, that's correct. We are going to turn left, and the turn left block we will find under actions. Before we do that, I'm just going to add a comment for myself, and we're going to call this the first turn. Right. So after we've turned left, we obviously have to move forward twice. Yes, very good. And then we have to do something again. Turn left again. Good. Oops, I accidentally chose turn right, but you can just switch the toggle. So now we can test this again. And I would always advise you to test the code as you are writing it. Where possible, it's not always possible, but where you can do it. Okay. Now we have this second row. So I'm going to put a comment in there. And I'm going to call it second row. Now I wonder if pick along path function will work here or not. Angelina, yes, turn left, good. So Jesse says, yes, it'll work. I'm not so sure, but I'm not afraid to test it because I know that we cannot break this. That's supposed to be a D. Sorry about that. Okay. So let's run it. And look at that. It works brilliantly. Okay. Now, again, in the chat box, tell me, how do we solve the second turn? But please take note that she's ending here. So we're not only going to turn. Our first turn started with a turn left, but with this one, we need to do something else. And move forward, yes, and then It's, excuse me, a turn right. Yes. There we go. So if we run this to make sure, it works perfectly. Now the last one that I'm going to label it, you don't have to if you don't want to. We can call it the third row or path. They refer to it as a path. I call it a row, doesn't really matter. The comments are for ourselves. It doesn't act out anything. Yes, the function, pick a longer path or pick a long path. There we go. And look at that. So here you can see our space here is a lot less. We're using 4 less blocks in total, so that's not a massive save. It is a save, but it's not that big. But your space here and your readability on your actual code here. There's a function, there's a function, there's a function. There's our code. Look at that. Earlier, if I wanted to show you all the code, I had to scroll up and down. Here, from the first row to where we finish, we can see all the code because we have created, or they have for us created this function here where they call on other functions within a function. Okay, so this function has a repeat and two other functions in it. Right. Okay. So I'm skipping this little square diamond here because I don't want to play the videos. What I am going to do is add this into your chat box. And this one is going to be homework. If you would like, you can share it to me. Let's just read functions. Let us do more with less work. Okay, so there's a little pun, a play on words for you. Create a function that sends the harvester down a square path to pick a single head of lettuce from each or from the middle of each row. The function is not defined. So you have to define the function. You're going to place it there. You're going to give it a name, okay? Whatever name you want to call it. And you are going to add some code into this, right? That maybe looks like that. And then you can call on that function where you want it to happen. And then you see that one will work. So there's a small hint for you, okay? It doesn't have to look like this. It can look whatever way you want it to look like, okay? And you'll see once I delete the function from my workspace, it's no longer available to choose. So you can keep this link open in your browser tab after we have finished this lesson. And if you want to then share that with me, I would be grateful to see what ideas you can come up with. We were going to do up to puzzle number 9, and puzzle number 9 was the homework. Great. So for tomorrow, we are obviously going to review puzzle number 9, and we will try to go all the way to puzzle number 12. If we do not reach puzzle number 12, that is okay, because as I said, we want to go slow so that I can make sure you understand this. Okay. Thank you for being here today. I really hope that you enjoyed the lesson and that you really understood everything that we spoke about. If you have any other questions or you would like to share your ideas with me after having done this homework puzzle, just make sure to take a screenshot. I've received a few things from students and either they forgot to put the attachment there or the link isn't working. So just make sure that I can actually see what you're trying to send to me. Then you can send it to my email address. There it is. And you can find us on these social media platforms, Facebook, Instagram, Twitter, by searching for Africa Teen Geeks. All right. Thank you so much for being here, guys. I will see you again tomorrow. And you are welcome to invite your friends. Okay. Thank you, JC. I saw that you have sent it to me. I will check it as soon as we are done here. Have a great day, guys. Bye-bye.